sessions, this kind of technical session is not to sell products. They are selling technology. Not even selling technology, they are sharing technology. So that at the end of the day, so that you can enhance not only you, but the people around you, or the design concept. So this time round, the fourth technical sessions, I think we have, or rather I have a very high privilege and honor to have our guest speaker here, Mr. Max Chiew. Mr. Max will share with us today all about pumps, the application, the standards, and the various and the evolutions of the pump.
First of all, we talk about the types of pumps. So I'm going to quickly go through the history of pump, the types of pump, how is it being used, what are the components in the pump. Stage, double stage, multi-stage, horizontal, vertical, pedal tube, special pump, high pressure, low speed, high speed, axial pump for irrigation. Many. There are many in the market. How does it look? These are all the type of pumps. Right. So in pump industry, you normally classify pump as OH, BB, or VT. OH, overhung design, BB, between bearing design, VT, vertical turbine. Right. But pump has not changed design for the past 50 years. Has not changed. Material change, the process how to make a pump change, how you make the pump. Last time you used to have to cut a mold, you have design a mold, measure, make out the wood mold, and then you go and cut. Test the pump, fail, then you go back. Now you have 3D printing. Now you can make a pump within 30 days. Previously it's 3 months on average. Right? So you see technology at advance, things at advance, things change. I will not touch, okay, there are many slides here, sorry, so I will not touch, but more important what we look at. Pump. Inside the pump, there are only a few components that's important. The impeller suction eye, the casing, the discharge, of course there's suction here, and then there's a cut water. The pump, whether how efficient is the hydraulic inside the casing. Alright, this is the major part. Okay, now this is, I'll quickly run through again the type of different casing. Circular casing, single volute, double volute. If I look at this casing, this is not for water, this is for slurry pump, solid. Because the distance between here and here is equal. Fire pump is not, the priority is to kill the fire. But if you cannot, then what you want to do? You want to contain the fire. So what happened? The fire brigade can come to fight the fire, more engine. Okay, this is the concept. Now coming back to this, you see this drawing here is a single volute. The water comes into the eye and comes out discharge. For a split casing, is a double volute. That means the water will come in one left side and go on the right side. Double the capacity. So sometimes you go and then your engineer say, hey, how come the split casing no flow? Or 50%? Rotation wrong? Maybe. What else? Or maybe the flow of the water going to the suction only go to one side only. That means the piping on the elbow coming on the suction is set up wrongly. A lot of technicians goes into the field and I say, hey, the bearing no grease. You take the grease gun and you go in the pump. The whole grease gun this big and you finish all the grease on one bearing. So the question is it good? You got too much grease. A ball bearing must turn. This is the shaft. This is what we call inner race, outer race, and this is the ball bearing. As the shaft turns, the ball bearing also must turn. If you have too much grease, what happens? It's like your car. Dry day, your wheel turn. So if a wet day, your wheel skid. What happens when you skid? You have no control. Same principle here. If your bearing is over lubricated, the bearing will not turn. The bearing will slide. And what happens when you slide on a metal over millions of times? you destroy the ball bearing. Alright? This is just type of design for pump. You have vertical because the shaft is different. The pump industry decided to say, hey, no, if it's a vertical pump, the shaft must be vertical. If it's horizontal, the shaft must be horizontal. So there are two planes, vertical plane and horizontal plane. Each has its own uses. So this is the term that they use. This again is a vertical turbine. Again, the discharge, this is above ground, below ground, above ground, vertical turbine, axial pump. All these are different based on the design of the impeller, the shape or angle of the exit. Axial pump, the water goes in, it comes out 180 degrees, the flow. Radial pump, the water goes in, but the discharge goes 90 degrees. Right? I go back, like this. The water goes into the suction, the discharge comes out from the top. 90 degrees, radial pump. So you have people, they are very creative. They say, hey, my pump is a radially split casing. Scratch my head, what is radially split? Radially, still have to split. But it's just basically say radial sign. Right? This is in and this is out. You notice the shaft is also turning this way. And the angle of the vane is facing this way and not the other way. Negative suction and positive suction. That's it. Big pump, small pump, tiny pump, very big pump, acid press pump, but everything else, negative or positive. That's it. Alright. So you go to a site and you say, oh, my pump is a negative suction, but my pipe is very near. He forgot to tell you, this near the hose is 300 meters long, but it's just beside the pump. So you need to find out 0.4 megawatt turbine engine. Right? This one is for oil fuel. Same, you see, straight away come out negative and then straight away, I'm sorry, I think it's not clear, but there will be, you see this? The common header, then straight away goes into the pump. There is no distance for the water from turbulent to become linear. You must give water a go. You are the king, you are the decider. You decide whether the pump will survive or not. You are God. Alright. Same here. You see this bend, one bend and then two bend. Right. Look at this multi-stage pump. This is even worse. Straight away the inlet coming, you go into the pump. Right. This is in Singapore, unfortunately. Alright, you see the pump behind, the tank below. This pipe very long. The contractor say, oh, the tank is just below. So after repairing, it still cannot work. I don't understand. So decided to say, can I see the tank? Ah, can. We walk almost 200 meters away to see the tank. Because below the ground, the pipe was running below the ground. I say, oh, okay. Now I know why the problem. Because this suction here is negative, you MPS it for problem. You open up the pump, all the impeller become this big, become this small. Because it got eaten up. You know what? Why this impeller? These are all impellers. Why the impeller got hole? Anybody can tell me?
Air coming in the church.
Oh, this guy is smart. Air coming in is called cavitation. That means air can do this, no? This is harder than air, no? This is harder than air, can do all this, you see? It's because of the suction pipe. The MPSH, net positive suction head required and available, they don't match. When they don't match, they create millions of bubbles. So what happened here is that instead of having this much space for the water to come in, now I'm reduced to only so little. This is the problem. This is where your impeller starts to vibrate. Your shaft starts to bend. The shaft starts to break. Your bearings start to fail. The mechanism starts to break. You just go down the line. Your pipe starts to have problem. Your pressure gauge starts to drop off from this holder. These are all common things because of all this. Alright? So what you want to do is you want to be at the best efficiency point. Okay? This is a better picture of just now. So you see it create a turbulence. Because of this recirculating, it's not going out. Huh? So you stuck here. So you look at the amount of fluid that goes in, it's only this part only. Very little, half. So suddenly you go and look at the flow meter and say, hey, how come only 50% performance only? This is the reason. You got to look at the suction. You put a sink. What happens? What you see? The swelling. Swelling is okay. It shows you two things. It shows you one thing, that liquid never flows straight on. You flow in a circular motion. That's one thing. So that's why your drain pipe, you put out there 10 inch, but the water still on the side of the pipe. We never go in the center one. Right? Because of the differential static pressure. Okay. But come to vortex. What vortex does for you, especially for fire pump or for any tank contractor, is you suck in air into the pump. Why? Because here is all air. So that's why you have a minimum submersion or minimum depth for the inlet pipe. Yeah? So for this, vortexing will draw in air. And air is meant for pump. Then what you start to hear after you got air inside, right? Like cavitation, you hear not smooth. Now, if you listen carefully, cavitation occurs very constant. Vortex is different. So you know whether it's vortexing or it's because of cavitation, whether it's sound. I always tell our service people, there are 5 things you always want to do. Touch. Hear. You can't taste. The next thing is run. Because when chlorine gas is in the air, you better run. But seriously, 2 things you need to do. Always touch, feel, look, and hear. You know the problem of the pump. Okay? Okay, sorry, to cut short again, the piping layout. This is recommended. That means before the suction, there must be at least 5 times diameter. What does it mean 5 times diameter? If my pump is a 4-inch inlet, that means I might have a 20-inch or straight pipe before elbow or before anything else. Same with discharge. You see here on top, there is an air vent. This is a common problem with a common header for fire pump. Because at the top, the air trap here, if you don't have an air vent to vent the air, all the air will be down there. This is the recommendation, not I say, but many engineers say that this is the best practice. If you look carefully, it's all about your pipe work and the suction. Cavitation is about suction. Right? Your vortexing is about suction. Right? Your water hammer, okay, obviously this has to do with the rotation where it stops suddenly, acceleration, but it's in some way also related to suction. I guarantee you, out of 10 times you have a problem, 9 times is because of the suction. First thing you do, you go down there, you look at the suction. That's all you need to do. The rest is just mechanical failure, warranty, manufacturer don't put properly, the impeller to trim correct size. One of the trick, this old man was 60 years old, was attending this seminar. He says, Max, he asked me a question. He said, Max, I have this pump. How I know my impeller is the correct size? How I know? By only closing the discharge valve, I know the impeller size. This guy is bonkers or too much beer already. Right? And this old man, 60 years old, he's not retired, seriously. He's working on DuPont for 30 over years. I said, Mr. Chia, can you tell me? No, he said, no, tell me how you got it. Oh, of course, take out the pump and measure lah. Oh, you stupid young man. I just turn off the discharge valve, look at the pressure gauge, the pressure, look at the curve, I know the impeller already. So, for any site, If you think you want to save $100 pressure gauge, let me advise you, don't save on pressure gauge. You will save your life. This is the single most important thing. And the cheapest way to troubleshoot a part. Why? Now, you know pump has a curve. You trim the impeller to the correct size. You go to the pump, maybe after 10 years old, no curve, out. What you need to do, put a pressure gauge on the discharge, close the discharge valve. Because close the discharge valve, what do you mean? Zero flow. That means you are on the zero line. And you look at the pressure, you look at the curve. If the pressure is 100 psi and the curve is 100 psi, that is where your impeller size is. A good suction design. This one, somebody told me about it. Rule number 1, provide sufficient MPSH. That means the suction line as straight as possible. Rule number 2, reduce the frictional. That means you increase your pipe size. Rule number 3, no elbow on the suction fan, if possible. I don't think it's possible. Alright. Rule number 4, stop air or vapor entering the suction line. So the gasket, the valve, the packing on the valve must be tight sealed. Now, the other one thing that for suction pump enemy is the air that goes into the suction when you run the pump. It's actually not good for the pump. Rule number 5, correct piping alignment. Now, correct piping alignment. You know, piping alignment got angular displacement. That means the two-phase is not straight. Sometimes the contractor comes and then makes but you know, it's just that because it's too low, what they do, they force the pipe. So this is prevented. Angular displacement, that means the flanges are not flush against each other. My pump is flat, but my flange coming is not flat. Torsional displacement. The 4-hole and let's say NC pump, the 4-hole of my flange and the 4-hole of my flange on the pipe are of different angle. So this is what it meant, correct piping. Rule number 6, when rule 1 and 5 has been ignored, follow rule 1 to 5 again. I can operate the range between 100 to 150. That's NFPA 20 requirement. Okay? Now, the condition now happens. Now, after I select the pump, the shut off, the line here must not be more than 140% from my rated. Second point, the head drop at 150 should not be less than 65%. This is NFPA 20. But if you want to give UL listed, there's one more condition. Very important condition. At 150, the suction lift must be able to do more than 3 by 8 meters. It's not written in NFPA 20. It is written in UL. So a UL pump that passed, he has to meet all this plus the NFPA 20, the net positive suction head must be able to lead 3.8 meter at 150%. Then this pump, it is a UL listed according to NFPA 20. Type of pump used. Can we use split casing, single stage? Can we use a split casing, double stage? Can we use a vertical inline? Can we use a vertical turbine? Can we use an end suction? Or yes. But vertical turbine, you must use not a sump pump. There's some in Australia allowed. Single stage, use the end suction, turn it upside down, put a column pipe, put the motor outside, it become a vertical turbine. Cannot, eh? But NFPA 20 also don't allow. For your information. Okay? So, again, sorry, not too clear the picture, but as a general, the setup of a system consists of one electric, one engine, one jockey. The controller is one electric, one controller, one jockey, one controller, one controller. Singapore, 3 in 1. Singapore believe in save money and be efficient. But they didn't think. Seriously, I'm not joking. And now they changed to individual panel. They didn't think, what happened if you got eddy current and cross wire? The whole panel don't work, your pump don't work. That is the reason why now Singapore, some of the fire code has changed to a single panel. Combined panel, that means all these 3 panels all put together into one. Okay, so this is the thing. So the system consists of the pump, suction, discharge, non-return valve, but they also have one system called the flow check. I understand earlier on we were talking with one of the gentlemen, they were saying that, not here, that the domestic tank and the fire tank is the same. And they were asking how to prevent the oil from getting into the tank. I say, sorry, I'm not God. I don't know how. Because there's no way, because the grease, everything will go inside the water, then you're drinking. But more importantly, as I said, all fire pump must be packing, right? Do you know asbestos? This material called asbestos is black in color. Do you know what is the effect? Maybe 20 years ago, all around the world, the pump decided not to use asbestos. You know why? Cancer is proven. So if you ask for fire pump from your supplier, please make sure they give you Teflon or pure graphite packing. Do not use asbestos, because it may not harm you, you may not know now. 10 years down the road, you'll be queuing in the hospital. I guarantee you. And it's true, it's not, I'm not just frightening you. Okay, because it's packing. So please be sure of this. Okay, the flow meter is weekly checked. Fire pump, there's no such thing. Hey, I want to test. How should I test? Take a lighter, go to the sprinkler and activate the sprinkler. No. There's a flow meter here. Yeah. So it's just a bypass. You lock the rest and then you bypass. You check the flow. Okay, flow enough, pressure enough. Okay, the pump system is good. Right. NFPA say every month. Singapore is every year. I'm not joking. The requirement is 3 months by SCDF. Okay, but I go to the guy who maintains the fire system. How you all do? 1 year, sometimes maybe 2 years. So when the fire, I don't want to be around. Okay, now the fire pump. The most important part of the, other than make sure alignment all this, the most important part of the fire pump is the controller. The controller is the heart. It tells me when to start the pump. It tells me whether not to start the pump. So you have controller, you have a diesel and electric, and under this you have what we call full service, limited service, horsepower of the motor, voltage, and other withstand rating and starting method. So here normally you have Y delta, star delta, soft starter, auto trunk, across the line, DOL, VSD. There are many ways of starting. In Singapore, most of HDB are all VSD. Reason is because we are using 2 electric, and our generator energy, what we call e-source, the end coming is not enough. So using VSD, the surge current is only less than 10%. This is done is because in case there's no power coming in into the electric, you need to bypass it. I think maybe for the big buildings here, you will definitely design them. Okay? I'm not going to touch more on this. Okay, this is a very important thing. Now the question is, after you buy the pump, you install, how you start the pump. How does the pump start? Okay, this is where it starts. First, this is time. This is 100%. That means the pressurized, the pump is fully primed. The whole system is pressurized. Okay? Now, first thing, the pressure starts to drop. 5%. The main pump start, may not be. You remember I told you maybe the fitting loose, the water leaking, maybe someone in the hose wheel turn on the hose wheel, wash car, or take some water for cooking, I do not know. Or some of the fitting maybe a bit, or the valve is a bit loose, the water leak. You do not want to start the pump because there's no fire. So what? The jockey start. So when the pressure drop hit here, the pressure sensor pressing line will sense, hey, you already dropped 5%.
Start the jockey will start. The pressure builds up. If the pressure reach 110 psi, which is 10% above the churn pressure, the booster pump cuts out. This is a scenario 1. Scenario number 2, the pressure starts to go back, but the pressure still drop and drop some more. Another 5 psi. From here, it dropped another 5 psi. What happened? That means, hey, guys, there is a fire. Main pump start. The main electric pump will start first. Okay, jockey pump, okay, maintain. Somebody go and fix the valve, okay, the pressure builds out, the pump cuts out. Okay? Another scenario, the pressure drop, jockey start. Hey, but the pressure still drop, another 5 psi. That means there's a fire. Of course, here in Singapore, we put about 20 psi. Here he asked for 10 psi, very sensitive. We don't need to follow 100%. It's up to you to decide. Normally it's about 20 to 25 psi. The main pump will start. It's a delay start. So the main pump start, pressure start to build. Cannot stop, right? Remember we say once it starts, the pump cannot stop until it manually stop. But if you start the electric and the pressure still drop, what happens? There are 2 things that can happen. 1, mechanical failure on the electric pump, and 2, electrical failure. Mechanical failure. We ever have pump that we installed for almost 10 over years. The coupling break. Right, the coupling break, because my control panel now sends the signal I'm drawing in. The motor is still running 30%. Right? I cannot switch over because there's no interlocking. So the fire burned because my coupling broke. So you must have an interlocking. We normally fire pump will come with the voltage monitor on the 3-phase. Okay? Because when the motor runs, you draw about 30% of the amp. And this amp will not start my engine. So the voltage monitor device will say, hey, 30%, more than 8 seconds, please start the engine. My pump is not giving pressure. The pressure drops some more. So the sequence is like this. It's just for common understanding that we understand the same thing. As I said, my main G's of NFPA 20 is understand the code, understand who is certifying and all that. Alright? Okay, engine, we talk about spark ignition and compression ignition. Okay? Any fire pump that has a diesel, has an engine, will never, you cannot use a spark ignition, you must use a compression ignition. Okay? Okay, the fitting on the pump. What are the minimum things you need? As I said, pressure gauge definitely you need to have. The next thing is the air relief valve and the casing relief valve. Now, the casing relief valve is only for electrical driven pump only, not on a diesel engine. Diesel engine do not need a pressure relief valve, but only electric only. They allow you to run 10% more. But the problem here is when you select the system pressure or the system relief valve. If I allow to run my pump 10% more, what is my head increase? Let's say right now, this is wrong. Let's say right now my churn pressure is 165, right? And I run 10% higher. This is 10%. It is wrong. Infinity law tells you that if you run your speed 10% higher, your head rise is 21%, not 10%. It's not linear. There is a law that governs the centrifugal pump. Q2, which is a new flow, okay, is equals to the new speed divided by the old speed times the old flow. But for H2 is equals to the head, that's the head pressure, is the square root of the new speed over the old speed. Square root. So if right now you're running 10%, 2009, let's say easier, let's say 1000 RPM, and then now you run 10%, 110%. That means theoretically your head will increase 21% and not 10%. So when you design your system and pressure relief valve, if you put 10%, the valve will always open, never close. And the pump will just keep on running. So this is the important thing that you must consider. It's 21, not 10.